Hello dear student, we are here. This is first time I am coming up with class 10th note on electricity because so many days I could not manage with my time to go for class 10th concept of any of the chapters. So first we'll start with electricity chapter, and before going to the typical notes or NCERT, I'd like to concentrate on what is meaning of electricity. When we talk about electricity, we are very sure that we are talking about electrons. Even in junior classes you have done this. Suppose say you have a conductor and you have conductor made up of various atoms, millions of atoms. And atoms have their different structures, and depending on the structures they have some external electrons. They might be having external electrons. The best example I prefer to give is Na. When you talk about sodium, if I take sodium and sodium is atomic number is 11, so I have electron distribution like this: 1s2, 2s2, 2p6, so 5, 5, 10, and 3s1. That means this one electron can be easily given out to get the octet format. If you have that structure that we can give out octet format, then we can easily say that we are talking about one extra electron, and this electron is considered to be free electrons. Means this is available, and this is free electron. So that means if I take some conductor who has got certain structure like this, ऐसा ही इसमें electron free रहेगा. So we have plenty of free electrons in some cases, and when you talk about electrons like this, we have abundant number of free electrons because millions and millions of atoms are working in this, and we have abundant number of electrons in this. That means by some means, suppose that this is your conductor, by some means you make the electrons move. You give a kick to the electrons. Say suppose I give a battery, and the battery is like this. This is a chemical source. So this is negative terminal, this is positive terminal. That means this can supply abundant number of electrons, and those electrons will come here and they will kick the electrons present in these atoms, and electrons will come pump out like this, and the circuit is on, and it will be continuous. If we have structure like this, if we talk about this, then we have serious problem that we have atoms are the commuter, atoms are the medium through which electrons are jumping from one to another. Suppose say one electron of this is kicked out. I'll change color to make you understand electrons much clearly. So suppose say you have one electron kicked out here, so this jumps here, and then it kicks out the electron of this, and it jumps here. We call it hopping. Hopping of electron is making the electron flow. One more thing I'd like to say in between, this lecture will also help plus 12 students to clarify the basics, though some of the formulas I avoided because keeping class 10 in mind. So some of the formulas are not discussed here, but this will be helpful for class 12 students or even higher students for getting into the basics. And you can pause the video and see this very carefully so that you understand it carefully. And now after this we talk about the hooping. So that means this atom, all the system of atoms here of a metal piece is at suppose say 0 degree or 20 degree centigrade. There is quite high temperature. All atoms are in vibrations. So when atoms are in vibrations, that means the hooping, the jumping won't be successful. The electron from this to this might not fall in this. It may come somewhere here or attack the other atom. That means the whole system is getting further disturbed, and this is going to lead to a total loss of electrons reaching here. Though number of electrons entering here will be same as number of electrons coming out in the output, but even then the whole process is totally disturbed by the time, and the whole metal piece will be heated up. This will get heated up. Obviously this will get heated up because vibration will be furthermore increased because of the interactions of the atoms and electrons. So think about 20 degrees, it's quite high temperature for metal atoms to be in vibration. Think about 0 degree, even that is very high temperature, or minus 273 degrees centigrade, minus by 0.0 degree centigrade, absolute zero. that is 0 degree Kelvin, is also theoretically a factor. Anyway, I'm not going to discuss all this matter right now. I'm more concentrating. Now, this loss for which some heating effect is created in this, we can call this to be resistance produced by the conductor. Keeping all these factors in mind, you must have noticed we talk about Ohm's law that says temperature remaining constant. Ohm's law starts like this: temperature remaining constant. Very important term, temperature remaining constant. Voltage is proportional to the current flowing in the conductor. That means if you have potential difference between this point and this point higher, the amount of current will be more. Let me explain this much in details. Suppose this is a 5-volt battery. Here at this point we have 5 volt, at this point we have 5 volt, at this point also we have 5 volt. This is negative side, so I'll consider this side to be 5 volt. This is also 5 volt. Here also I have 5 volt, and at this point also I have 5 volt. Here I have negative, so it is 0 volt, and this is also 0 volt, and this is also 0 volt. That means the potential difference between this point and this point is coming to be 5 minus 0, that is 5 volt. If I increase this, suppose I make it 15 volt, so it will be 15 volt. It's common sense. The number of electrons supplied by a 5 volt electron source or 15 volt electron source won't be same. 15 volt electron source will supply more number of electrons and kick out more number of electrons. So the current means nothing but, current is nothing but charge by time. So this is what the current is. Charge means, I'll discuss little bit. Charge means the electron has got negative charge, and where you have devoid of electron, we can consider that to be positive charge. In class 10th, you don't need much details of this, so even then I'll try to explain you a bit, but in 12th you have elaboration of this. So you have charge by time, that means you have charge by time here. So number of charges are more in same time, that leads to increase in I, because T is denominator and Q is in the numerator. So if more number of charges flows, current is more in the same time. That means the voltage is proportional to I. We can estimate that value, that voltage is proportional to I. If we know this, then we can talk about more clearly that we are talking about voltage and current. So one factor, wherever you have proportional sign, please notice this, we can get rid of this proportional sign by equal sign if we bring some constant in this. Now what is this R? R is the resistance. Just before this I explained you R. R is nothing but this, that the nature at which certain temperature by which the atoms of that material vibrates, helping or diverting the electrons coming out from in the flow, is considered to be resistance of that substance. So there are two terms we'll come across, but right now I'm concentrating on resistance. Then we'll discuss about resistivity. Please don't make confusion regarding both. Resistance and resistivity are not at all same. So if we have this formula, then we are very clear that we have proved Ohm's law. This is the Ohm's law, famous Ohm's law, what you call Ohm's law. That means here it is said V is equal to IR. This is one of the crucial formula we are going to discuss and implement in the whole chapter. Now that means now we know what is resistance partially, and now we also know what is potential difference or potential, that is also partially, and the relation between current, resistance and potential. Now if I go to the concepts of the topic, then I can say, please concentrate here, electric current, this definition. This is the note. If you want, you can email me. I can send you PDF of this note, but otherwise in YouTube I cannot provide the notes. Electric current is the flow of electrons through a conductor. That means what I defined, what I expressed now, that is very important here. One more thing, I is equal to, electric current is expressed, I is equal to Q by T. One more very important thing, and unit of ampere, current is ampere. Now one more thing, very important thing I must discuss here. When I say I is equal to, when I clearly say I is equal to Q by T, there's another formula. I must discuss about charge very clearly, because charge is the beginning of understanding the current electricity topic. So when I talk about charge, what is charge? I discuss something right now, that one electron access remaining in the whole system can be considered as charge. So suppose say I consider this to be charge, one atom like this, and one electron is left here. This can be given out like this. Suppose two shells are there, one electron can be given out, and here two electron, whatever it may be. So I can give out this. This is what we call free electron. This is what we call free electron. So free electrons are the thing which are actually negative charge. We consider them to be negative charge for namesake. But one thing is very sure, you must understand this: quantization of charge. There are some properties of charges. Now there can be question on charges and properties of charges. So charges are actually, they are always, we call them quantization of charge. And the first I'll write here, quantization of charge. Quantization of charge. That means we cannot make charge to be fraction. Go by simple logic. You have one electron access or two electrons access, so it cannot be 2.5 or 1.5 or something like that. It has to be a whole number. So it has to be one fixed number. So we can say, if E is electron, then we can say Q is equal to NE. Very important formula. You are going to implement this. This E is electron. Please remember this. E is equal to 1.6 into 10 to the power of 19 minus 19 coulomb. This is the value of E, electron, in the charge in electron. And now you may ask me, this is in fraction. Yes, of course, you can consider that to be in fraction, but this N will be never in fraction. Please remember this. This is never in fraction. This will be either 1, 2, them in fraction. So N is equal to either 1, 2, 3, and so on and so forth, all integers. That means if I go by the critical question, I is equal to Q by T. Instead of this, I can write N E by T. This is also possible. So N is the number of charges you have. Suppose I have 1 here. In some other atom there can be 2. These are the numbers. Specifically here for this case it is 1, and E value remains fixed, and T is another factor by which you can easily calculate out I. Am I clear? Now let's go to the note back and let's discuss this. So ampere is 1 coulomb by 1 second. That is very simple as per definition. This description in the note exactly says how actually a battery is running, pumping out electrons, what I discussed, and the lamp itself is a resistance actually. The lamp they are showing is nothing but a resistance I shown in circuit, and that is actually the whole story. Now current and electron flow. You talk about current and electron flow. What I described there, it is exactly mentioned here in this. Now electric potential and potential difference. So two things should be very clear. Potential means energy. In class 9th you have done potential is nothing but energy. When we talk about potential, we are actually talking about energy. So whatever energy you have, that is same as work done. So potential difference is nothing but work done by charge. See, clearly this is mentioned. Potential difference is work done by charge. That means in the circuit, when one electron is being pushed, suppose say you have a circuit like this, you have a battery like this, and a resistance here, and this is my positive, this is my negative. When electron, the work done, one electron takes a path like this and comes back. That is what potential is. Under these circumstances, the energy that is supplied by this, that is work done by this, is the potential. Now who is facing the work done? It is the charge who is facing the work done. So work